Okay, here we're going to try something really cool. So we're going to compare the antiderivatives of these two functions, all right? And as you can see, they look really similar because they contain the same kind of functions, but with different arrangement. So here they're just the product of x, that's the identity function, and then the natural logarithmic function of x. And then here is the ratio, where we have the natural logarithmic function at the top and then the identity function below. All right, now the way we're going to tackle this, we are going to use very different methods, all right, of integrations. So the first one here, we have the product, and these two are very simple to handle, right? But here we are going to use the integration by parts formula, all right? But I'm going to do this in a very simple way by just creating a table. We call this a table method, or if you like, you can call it a DI method. This D stands for differentiate, and then the I here stands for integrate. And then we're going to do this, we're going to put an addition sign here, then we're going to put a subtraction sign there. All right, great. So how we're really going to make use of this is by choosing a function to differentiate, and then choosing a function to integrate. So we have the product of two functions here. Well, which one can we really choose to integrate and differentiate? Well, let's say if we make use of x, if we want to differentiate x and integrate the ln, you know that the antiderivative, or to integrate ln, we need to make use of integration by part. So instead, I will choose to integrate to differentiate the ln of x, right? Because it's going to be a lot more easier, and then we can just integrate x over here. All right, great. So the derivative of ln of x is going to be 1 over x. That is pretty simple. And then the integral, or the antiderivative of x, is just x squared over 2. Okay, very nice. And now that we had that, when we are done with that, what we really do is this. We are going to multiply this out this way. Diagonally, we are going to multiply these two together, and then we are going to also multiply these two together, and then this second time we are going to be doing integration. So we multiply this out, and then we multiply these two and integrate these two, right? So what I'm really saying is this integral will become, this right here will become the product of these two, that will be x squared over 2 times ln of x. All right, and then we are going to multiply these two together. Keep in mind we have a negative sign here, so minus this product, that is going to be 1 over x times x squared over 2. But this time, when we multiply this together, we are going to have to integrate the product. All right, so keep in mind that is the way we go. And then this is, we are going to keep this as it is. We don't really have a lot of work to do here, times the ln of x minus, now look at this, let's do a little thing in our head. This is x and this is x squared, so when we cancel out, we are going to have just one x left at the top, all right? And then that will be x over 2. Well, the antiderivative of x over 2 will just give us x squared over 4. Okay, great. So we have here x squared over 4, and if you'd like, you can add an arbitrary constant, and this right here is the antiderivative of the first function. Okay, let's go over to the second one real quick. This second one is really simple. Now here I'm not going to be using this integration by parts method. Rather, I'm going to be using the u sub, or you can call it the change of variable. What I really notice is that if we take the derivative of ln of x, we get 1 over x. That means these two products are derivatives of each other. Sorry, let's just get on with it. So we say let u, they are not derivatives of each other actually. Let u be ln of x. All right, by change of variable. So if you differentiate that, the u will be, well, the derivative of ln of x is 1 over x. Okay, and then we just have to put down the dx over here. Okay, great. So that means that this integral will become, this will become the integral of ln of x is u, right? So that's very nice. So we can just put the u over there. And then you notice that this is 1 over x. This is like 1 over x. And what is du? du is 1 over x dx. So this is 1 over x dx, and that means that is just du over there. So if you find the antiderivative of u over the u variable, is u squared over 2, where u is what? Where u is ln of x. So this is equal to ln of x squared, right, over 2. And since we are done, we can also add an arbitrary constant, and this right here is the antiderivative of this second one. So you notice this and that, they are completely different results. Okay, great. Right, thanks for watching. Please subscribe to my channel.